And everyone deserves or should have a 5, but you should expect better and you should expect more. Don't settle for less than what you're capable of, and you're all capable of more. So, with that being said, I already talked about the mock exam. I got 2 more people who still need to do it, but that's a very, very strong start. I'll go ahead and tell you this, I've never had that strong of a start on a mock exam. I've always had at least a couple people make a 1 on the mock. And no one's ever made a 1 on the actual test. That's the good news. But that means we can all clean it up. And there's a lot of small details that we're going to go over during review. Like I was even showing Deacon. He was like pissed. He was like literally that 1 word, right?
Oh,
and there was like 2 or 3 places. Hey, you and I both know we talked about it, right? Yes, Austin.
So is it true that if I had taken it after we went over that stuff, I would have made about 5?
I don't know about a 5, but because you barely had that 4, but you're not that far away from a 5. All right. So, with using and interpreting the least squares regression line, determining if a model is appropriate and the best explanatory variable. That's what today is all about. So, we talked about this. What is that LSRL here? Least squares regression line, okay? So when we talk about that least squares regression line, what is that?
It's a regression line that has the least squares.
Yeah?
Squares that away like how much the data varies from the line.
Okay, so it has the least squares. I'm going to come back to that idea in a second, but what do we mean by it has the least squares? Like, why is...
Smallest squares from the line.
Yeah, but where... Okay, so let me ask this. Where are those squares coming from?
From the residual.
From the what?
I was actually residual.
The distance from what?
The
line. So the distance that those points are from the line, which is called the what? The residual, right? So what are we really doing? If we are minimizing the squares, we're minimizing the what? The residuals, right? So the least squares regression line, is that the only trend line, the only regression line possible?
Probably not.
No, it's definitely not, right? Like I could draw this one, right?
Aren't there infinitely many?
There are infinitely many, right? But which one is better? The one I did first or the second one? First, right? So what is the least squares regression line? It is not a regression line, it is the best regression line, right? On the AP exam, sometimes they'll ask you to sketch a regression line. And so it just has to be an approximation. Or if they give you the equation, you know how to be able to find the slope and the y-intercept and things like that. Things you've been doing since 8th grade, right? Graphing a line. We'll do a little bit of it. But that's the least squares regression line. And so we did that squared up task. If you were not here on Friday, that's the goal. If you were not here on Friday, then you need to watch that video for sure, because the squared up task is very, very important for understanding a least squares regression line. What else do we cover in the horsepower task? Yes, ma'am.
The notes?
Been here for them. But we started with for what day? Oh. Squared up here. That I'll have to find a copy of the notes though. Hey, Mr. Arliss, can you look for a copy of the notes on the that back there? Oh wait. Yeah. Okay, I got it.
We won't be here Thursday.
No, that's 6. Yeah.
Yeah,
You're gonna be where?
oh, and all.
We won't be here.
You never like, you never like.
So Thursday or Friday? Okay.
The week after that, we won't be here Thursday through Friday.
But I won't be here Thursday, that's it.
Okay,
And I'll
so
watch the video.
y'all need to watch the videos and do
Well,
them.
we'll be home Thursday, that's a plus.
That's not a plus.
I don't know, that's still a lot of
I
time.
feel like
missing.
I'd be
Okay,
better one of the
So-
here.
really quickly, I also want you to have, so we looked at this, what else did we talk about in the squared up task besides just the minimizing the squares and what by the way, what is a residual? How do we calculate?
Actual minus predicted.
Right, so a residual is actual minus predicted. There's a really interesting little acronym to help you remember it. AP, right? Actual minus predicted. That's how we can help us remember the residual. By the way, why do we square those residuals?
Because some of them are because they'll just counteract.
Right, some are positive, some are negative, and so if we add them all together, we would just get 0, right? Okay, so we have to square them to find that least squares regression line. And so, what else did we talk about on Friday with that squared up task?
I don't.
There's 2 more huge things that we're going to look at in a second, but we need to be able to remember this.
The predicted y value,
Okay?
y hat.
Yeah, so y hat is a predicted y value. We just already talked about that. There's something later.
Dave wants being above or
Think
below
about-
the regression line.
It was something about interpreting.
Oh, predicted value, no, it's predicted something. It's like
So
a,
interpret, well, what are we going to try to interpret? Interpret the slope and y-intercept. We're going to come back to that in a second, but guys, you've got to know how to interpret the slope and y-intercept in context.
And this is just like rhizome, right? Like,
Ish. We're going to talk about, it's a yes, but there's a couple of small details to help with this. Yes, Bryson?
Are we putting that under where it says how you interpret it?
So we're going to talk about it within these set of notes in a second, but it's also, it should go into the squared up task, but we're going to talk about it more in a second, okay?
Yes, sir.
So this is the chapter 12 notes, or no, chapter 3 notes. And we're going to make notes about this, but I want us to go back to that squared up task. So we got to interpret the slope, y-intercept. What about, well, just how do we use a least squares regression line to predict? How do we use a least squares regression line to predict?
yeah, it's like just an equation.
So you plug into your,
Slope equation.
well, what are you going to plug into?
The equation.
Yeah, but what part of the equation?
The slope. It's like you usually have an X value.
I'm making up an equation here.
So are we in the notes or are we on the?
I'm referring to what we did, but we're not doing notes yet. I'm just doing a quick recap of what we did on Friday. Guys, how am I going to use this regression equation to get a predicted value?
Independent
It's
variable
y.
is X.
Thank you, guys. You have to substitute into the
X.
x, the explanatory variable, the independent variable to get the predicted value. Okay. That's a huge part. So, what is the general form of a regression equation?
Y equals mx with b, or a y equals x.
So why don't we look at the formula sheet? What does the formula sheet give us?
That's what b is.
The formula gives us a plus bx, right? This is I told you all this is the traditional way to do it. This is the, in my mind, a more sensible way to do it because it actually gives us our starting value first. What is this a here?
Is your y-intercept?
There we go, y-intercept, right? If x is 0, what does this become?
Nothing.
Nothing. So it'd be 0, comma, a. That's the y-intercept.
X.
Okay? So what is b?
Y. Slope.
Slope. How do we calculate slope, by the way?
Rise over.
What's another way to say that?
Y over
The
x.
change in y divided by the change in x. Okay, so we're going to come back to all that in a second because that's important. But there's something y'all drastically forgot about with this regression equation.
Y equals y.
Does it? Is that what it is? It equals y? Sure about that?
Y
Y
hat.
hat.
Remember, a regression equation is not the actual y value. The regression equation is the
Predicted.
predicted y value.
Can it be like the V,
Say again.
like a little bar over the line?
No, that'd be the average of y. I see what you're saying. So when we say this is predicted y. This is the average or mean y. Right? Anytime you use that bar over the variable, it's an average or a mean. Good question though. Glad you brought that up. So what is the difference between y and y hat? Y is the not a parameter. Why is it, well, pause and let's actually talk about that. Why is it not a parameter?
It's estimating a parameter.
It's not estimating a parameter.
Why not?
Is it predicted?
It's like a,
I can see, I see maybe a reason why. It's a point estimate kind of for a parameter, but it's the y values for the sample, right? It's the actual y values.
okay.
So that's why I say I could see the reason why you were thinking it's a, you're saying estimators, what did you say, what word?
I was saying like it's estimating a parameter, because you're estimating like y, so I just assumed you were still like.
Here's why I wouldn't say it's estimating the parameter, because that would be like x bar estimates mu, right?
Yeah,
Y hat is estimating y. A is estimating alpha, the y-intercept for the regression equation, for the true regression equation.
yeah.
B is estimating beta, the slope for the true regression equation.
Yeah.
But y is just the actual y value for sample data, right? So it's not a statistic. It's just a data point.
Okay.
That's why it's important. Okay. So it's important to recognize that y is not a statistic. Y is just a y value for a data point. Whereas y hat is what, Deacon?
Yeah, it has a hat.
Thank you. What does it mean though?
Oh, it's a point estimator.
Come on, there's something you need to immediately think of when you hear y hat.
Oh, it's the same. Well, I'm gonna say sample, but I don't know what it is. I don't know what it
Austin,
It's the point estimate. Right. Exactly, say.
it's already written on the board, guys.
I'm blind.
It's the what?
Predicted.
It's the predicted y.
Oh, okay.
Y hat is my predicted y. So a thing to notice or think about is when we say residual, AP is good, but remember the actual is going to be y minus the predicted is y hat. That's another way to write the residual.
Alright.
Okay, so y minus y hat, actual minus predicted.
Could you also say it's like the expected?
Yes, but be careful with that language, just because when we say the expected value, that kind of goes back to the idea of like a mean within probability distributions, or a mean. And a y hat is kind of a mean, but it's not quite the same, right? It's not quite an average, mostly because we have two estimates, A and B, involved. Does that make sense? So it's not, when we say expected, we say it is a type of expected, but the common or standard language is predicted. That's a good way to think about it though. Alright. We haven't used this word yet. Extrapolation. That was a good word.
Extended regression line beyond observed data to make predictions, but risky due to assumptions.
Okay. So when we say extrapolation, you say, let's break it down. Let's look at just that first word, and we'll come back to what you said, Peyton, because here's the thing. You're reading it from a textbook. We need to know what that means, though, right?
Alright.
When we say extra, what does extra mean?
Like more of.
Roasted.
Yeah, I am extra, and I'm proud of it. It's to what? I heard some people saying things.
More.
Too much. It doesn't have to be too much.
More than it needs to be away from.
More than needed.
So it's to go
Above.
beyond. Okay? Extra blank just means to go beyond, right? And so when we think about extrapolation, that means we're going to go beyond our what?
Regression line.
No, regression line can continue infinitely, but what is that regression line estimating?
Observed data.
The observed data, right? So when we extrapolate, we're going or predicting beyond or outside
The observed data.
the observed data. Okay? So extrapolation, this is a prediction outside
Where is this?
or beyond the observed data.
Such a fun word to say.
Extrapolation.
Yeah.
Okay? So when you hear extrapolation or extrapolate, think prediction outside the observed data. And that's why you talk about that regression line, right? Because our extrapolation comes from the regression line, but it'd be focused on outside the data
So
that we
you
have.
extrapolate based on the regression.
Right, because a line continues infinitely, right? And so we use that line to make predictions outside of it. Yes, Lexi?
So
Makes sense?
if it's a prediction outside or beyond, is it, I don't really know if this is a good way to ask, but could it be like below or above?
Correct, it could go either way.
Okay.
And so we're going to talk about, is it a good idea to extrapolate?
Yeah.
It's kind of like
It is,
a-
but it's
It can be,
risky.
it's a
It
judgment call.
depends on context.
It can be, you
It's the best way I can put it.
So-
It's really vague, but
I
I
guess
would
it
say-
depends on what you're doing. Yeah.
Well, let's put it in this context. I want,
it's kind of subjective.
not really, there is a clear reason why we can't, when we can and cannot. So think back to the squared up task. Does anyone remember what my independent and dependent variables were? The squared up task from Friday, what were our independent and dependent variables?
Oh, was that when you were running?
No, we haven't done that horsepower one yet.
The independent was the,
Pretty sure it was the year, right? We started in 1900, went to 2010 or so. What about the people?
Lifespan?
Their lifespan, right? So the year and their lifespan, right? So because that regression line continues up, eventually what's going to happen to this lifespan?
It's going to reach infinity.
It's going to reach infinity. Is that realistic?
No.
No, right? We ain't robots, at least not yet. So even robots would break down at some point, more than likely. So here's the thing. Is it a good idea to extrapolate?
It depends on what you're doing.
Depends on what you're doing. And a lot of the times the whole goal is to extrapolate, but we cannot extrapolate too far outside the data. Okay? And so that part is a judgment call. But a lot of the point of these predictions are to go outside the data, but only a little bit. If we go too far, then our data doesn't necessarily hold up. So, extrapolate a little outside the data. Okay. Okay, extrapolate a little outside the data. So, a contrast to that, I want to remind you was, what was our y-intercept for that squared up task? Anybody remember? We should have it written down.
That's a great question.
It was what?
Wouldn't it be the lifespan at the bottom?
Right, but what was that value? Couldn't be 0.278.
2948 or 0.294?
No, I think that was our slope.
I see so many numbers. 507.855.
Guys, where do you see your prediction line? It should be y hat equals. It should have been on the right-hand side where we wrote, see we have our slope and y-intercept should be somewhere. What was it? No.
482. Negative 454.
Thank you. It was negative 400 something.
Oh, it's right here. I just didn't. Okay.
I'm going to say that right now. Okay.
That's
Hey
the
guys,
lifespan.
we got to go back to we got to make sure we take effective notes. We got this stuff written down because we talked about this, right? And Josh got super upsetty about this. Okay? He was like, Mr. Kinney, there's no way to have a negative 454-year-old person. Is he wrong?
no.
No. So why did we get that value? Because it is dangerous to extrapolate too far. Our first data value was in the year 1900. This is in the year zero. Is that a little far outside of our data? Just a little bit. Do we see that as a problem?
Yes.
Okay? So, we can extrapolate a little outside the data, but we don't want to go too far outside the data. So, what is a residual? Somebody, anybody?
Here's the actual amount predicted.
Actual
minus predicted.
Hold on. I need y'all to hear what Haley is saying because I didn't ask how to calculate it. I asked what is it?
Distance the point is from the least square regression.
So it is the distance that a value is, either above or below the what? Least squares regression line. We gotta be careful with that language. Now, how do we calculate it? That's a different story. No, not just the calculator.
Y minus y hat.
Thank you. By the way, once again, as always, Deacon, can you hit the lights? Yeah, I'm gonna write it down in a second, but I want you to notice this, right? This information is in the textbook. Mr. Kenny's not making up random stuff. This is just good statistics. Extrapolation is the use of a regression line for prediction outside the interval of x values used to obtain the line. The further we extrapolate, the less reliable the predictions. Don't make predictions using values of x that are much larger or much smaller than those that typically actually appear in the data. Okay? And so you may have to use a judgment call in that sense. Here we go. So, a residual is the difference between the actual value of y and the value of y predicted by the regression line. That is how we calculate it. But what is it really? It is the distance between the regression line and the data in the y value. Do notice that distance is always how? What direction?
Vertical.
Vertical, right? The direction is always vertical to the line. That's why it's y minus y hat. Okay? Sir?
It's like not like the concept of not going too far. Does that mean that the line actually isn't a linear line?
No, it just means that you can get to unrealistic values, right? We can't have negative 454 years for the lifespan. It could be linear in the short run, but maybe not in the long run. Does that answer your question? Right? There is a limiting factor to how long someone can live. There was a limiting factor to the average lifespan on the low end. So that's why in the short run, it might be linear and we can make predictions a little outside, but you don't want to go too far. So yes, that's a good way to think about it. So I need y'all to pay attention to this right here. The interpretation, this was not on your mock exam, thankfully for us, but this does show up pretty regularly on the AP exam, is how to actually interpret a residual, right? So there was a regression line earlier in the book. They found the predicted price to be $26,759. That's for some F-150, I guess the price. And the actual Y value, the actual price was $21,994. So actual minus predicted was negative $4,765. So here's how it's actually interpreted. The actual price of this truck is $4,765 less than the cost predicted by the regression line. That's how you interpret it, right? So the residual is this much more or this much less than what was predicted by the regression line at this input. I would make a note of how to interpret, because you got to know how to do that either for multiple choice or for free response. It regularly shows up, right? So actual price, or the actual, I'm going to say response variable, so response value, is the residual, so the absolute value of the residual, either above or below the predicted value at x equals blank, right? So the actual, whatever that response value is whatever the absolute value of the residual, right? So it's just a positive value, either above or below, more or less than what was predicted at that x value. Yes, Austin? Sure. Okay. That is a regular thing that shows up on AP exams, will probably be on the test. Okay, I'm gonna talk about interpreting slope in a second. So AP exam tip here, so this is that second question that I want you to go ahead and look at on the notes. I think it says, what is the most common error that students make? Is that what the second question there at the very bottom is? So what is the most common mistake students make, do you think? Predicted, right? You have to clearly indicate that the slope or y-intercept is about the predicted response, not the actual response, right? That line is only predicting what the output values would be. So when you talk about your response variable, what word are you always going to use? Predicted, right? When you talk about that response variable, Bryson, what are you always going to use? There you go. Okay. So, with that in mind, remember I talked about this on Friday. I guess we'll just have to end here. We'll do the lab to start tomorrow. The y-intercept. What do you know about every y-intercept that's ever existed?
It's a y.
Oh,
X equals 0.
The x is equal to 0, right? Now, remember, what's the only part that's being predicted here? The y, right? So do you need to say predicted for the x?
No.
No, right? So that's the x. Put it in context. So x in context, 0 something. And so when that x or that independent variable is 0, then the y-intercept, which what letter do we typically use for y-intercept?
Y at?
That
No.
Remember that a
Yeah.
is my y-intercept, and the a is what you were saying, Deacon. It'd say what?
Wait.
No, what did you say just a second
Oh,
ago?
y at.
Thank you.
Oh,
So it is a predicted y,
so exactly.
right? So when you are asked to interpret the y-intercept, you need your x value in context, and you need to talk about whatever that y value is as a predicted y and also in context. So we talked about this on the squared up task, but I also want to put it here in the notes or on our FAIR models. So someone was talking about slope earlier as rise divided by run. We rewrote that as change in y divided by change in x. But first, what letter do we use typically for slope?
B.
B. And we talked about change in y divided by change in x, but what do we need to change about that for this slope?
In this case, wouldn't it be changing y hat?
Because it's not the actual y values, it's the predicted y values. Okay? So the slope is the change in the predicted y values divided by the change in the x. Okay? Again, put them in context. Make sure that you talk about if it's in, typically we're always going to let the change in x be an increase by 1 unit. Right? In context.
X.
And so for every increase in 1 unit in context, the predicted y changes blank, okay? So it is putting those numbers in a context.
So,
Yeah.
if you're like if you're interpreting the y-intercept
Yeah.
and you're saying like the year 0, for example,
Yeah.
would that be considered explanation?
So in the year 0, that's context, the predicted lifespan of Americans, I think it was, is negative 454 years. Is it realistic? No, but is that how you would interpret it? Yes.
They didn't do that
Yeah.
on the exam.
They have asked students to interpret y-intercept before, and if you had looked at number 5, they asked you to interpret slope. Yeah. So, we have 2 minutes left. So, yeah, we're going to start tomorrow. Hold on. We're going to start tomorrow.
9 more days.
We're going to start tomorrow with the horsepower lab, so wear shoes that you can run in. What I highly recommend, 10 more days for you because you're going to come the day before the AP exam. What I highly recommend for you is that, remember there was that last page for the squared up task. I can resend the data to you if you need it, where, and you're supposed to already have this down, where you got the regression equation and the sum of squares for these two contexts so that you can practice interpreting slope and y-intercept, so that you can find the predicted life expectancy.
If you're a member of the
and
Chick-fil-A Leader
practice
Academy, we're having
extrapolating.
a meeting in the
I would do this
library
page,
during enrichment.
get the data before you
email
leave.
is already
If I
been
need to
sent
give
your
it to you,
teachers
send a
explaining
file to you, let
during
me know.
enrichment. We'll see you in just a second.
Progress
Thank
check
you.
A is due tonight. I told you all about progress check A last week. It is due tonight.